Hello everyone. Today we're going to do one of our videos, redo one actually, and it's the math that is used for chemistry. There's three things that you really need to know mathematically to do well in chemistry, other than some formulas. But we're going to deal with the basic things. We're going to talk about first, significant digits. What are they? And how are they used in various ways? Then a second video is going to deal with scientific notation, which is used a lot in chemistry. And the last one is dimensional analysis. And so we're going to talk about these things because they are absolutely key to success in chemistry. Okay? So here is our first one called significant digits. Okay, scientific notation is based on significant digits. Significant digits. Okay, sometimes these are also called significant figures. Remember when we talk about digits, digits are the symbols used to make numbers. For example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These 10 symbols are called digits. Each one of them carries a quantity of meaning, okay? 0 means there's none there, and 1 and so on. So these digits are used to make all your numbers bigger and bigger and bigger, smaller and smaller and smaller. So these are the digits that we're going to be looking at. When we look at significant digits, though, there's some very interesting things that we need to know. First of all, what makes a digit significant? And this is where we get into the idea of zeros. When is a digit significant and when is it not significant? Okay? So, our first rule is this. Digits which are not 0 are always significant. Okay, that's the first rule. Okay, so 1 through 9. All of those digits are significant. So that's the first important rule to understand about significant digits. Rule number 2. When a 0 rule number 2 is going to deal with when is a 0 significant. So, when is a 0 significant? Okay, that's our question. The first rule for this is when it appears between significant digits. Okay, for example, 204. In this case, my 0 is between 2 and 4. 2 and 4 are significant, so therefore 0 is significant. I could even have something like this. 3 and 5 are significant, so these 3 zeros are also significant. Okay? The second rule that deals with this. When it appears at the right end of a decimal number. Okay, such as something like this, 3.50. You see your 0 is at the right end of this decimal number. Therefore, it is significant, making this 3 significant digits. And the last rule, and sometimes some of the books have another mark that they use, and I don't know what it is, but it is significant when it is marked with a line over it, or an overbar is another word for that. In other words, something like this. If I put that line over the 0, it makes that significant. Okay? When is a 0 not significant? So rule number 3. When is a 0 not significant? Okay, so when is it not significant? Again, this is important. It is not significant when it is at the right end of a whole number. Okay. For example, 4500. These zeros are not significant because they're at the right end, they're at the end of a whole number. Now, if it was a decimal number like this one, they are significant. And the last one is it is not significant when it is at the left end of a decimal number. Okay, example, 0.003. The only significant digit on that is this 3. These others are not significant because they are to the left end of that number. Okay. Now let's look at some numbers and see if we can figure out, are they significant or are they not significant? How many are there in these numbers? Okay. Okay, so looking at these numbers, our first number is 3.04. How many significant digits are there in that number? Well, 3 and 4 have to be significant because they're non-zero numbers. 0 is between 3 and 4, therefore it is also significant, making this one have 3 significant digits. Okay? How about this one? It's a whole number, there's no decimal in it. My zeros at the end of this whole number, at the right end, are not significant. Therefore, this number has 2 significant digits. Use an SD for significant digits. This one is a decimal number, 15.730. Well, obviously, 1, 5, 7, and 3 are significant. But is 0 significant? Remember, it's at the end of a decimal number, the right end of the decimal number, therefore it is significant. This one then has 5 significant digits. 1, 2, 3, 4, 5. Okay? How about this one? It's a decimal number again, but its zeros are to the left end of the significant digit. 5 we know is significant. These zeros are not significant because they're to the left of that number, and therefore this one has only 1 significant digit. Only 5 here is significant. How about this one? 18,400. 1, 8, and 4 are significant. Are these zeros significant? Well, this 0 has a bar above it. Therefore, that over bar makes that one significant. But this 0 does not have an overbar, so it is not significant. So 1, 2, 3, 4 significant digits. And now this one, 200.0. Okay, remember, this one is significant. Our question is this 0 significant? If this 0 is significant, it makes these also significant. Well, it's to the right of the decimal point, and it's after significant digits. Therefore, this is significant, forcing these two also to be significant. Thus, this number has 4 significant digits. So you see, these rules are really important. They help you decide what is significant and what is not significant. And that's important to be able to know. Okay, in chemistry you are going to be adding, subtracting, multiplying, and dividing with these numbers. And so you have to know when they're significant and when they're not, when you're adding, subtracting, multiplying, and dividing. So first of all, let's look at this a little bit more. Since the accuracy of the number refers to the number of significant digits, it is important to know how to find that number when operations are used, such as addition, subtraction, multiplication, and division. So, we're going to look at first what happens when you multiply. When multiplying or dividing numbers, the quotient or product must have the same number of significant digits as the least significant digits in the numbers used. Okay, so if we were to look at a multiplication such as 1.2 times 1.35. Well, first of all, 1.2 has 2 significant digits. 1.35 has 3 significant digits. That means after we do this multiplication, we are going to round until our answer has 2 significant digits, because this one has the least and that's how many our answer has to have. So let's look. If we multiply this together, we get 1.62. That one has 3 significant digits. We have to end up with 2, which means we're going to have to round to this place value. So this is going to approximately be 1.6. That has 2 significant digits, exactly like the least in what was multiplied. Okay, so now let's look at some more and practice this thing. I recommend, I'm going to list them, and I recommend you that you pause your video and then do them and try to find if your answers are correct at the end. Okay, so A is going to be 7.2 times 0.48. B is 0.18 times 3.15 times 20. C is 82.45 divided by 3.65. D is 28 divided by 1.25. And E is 2,450 times 3,178. And F is 148 divided by 15. Okay, so there's the ones that we're going to do. So going back now, let's look at our first one. We have 2 significant digits and 2 significant digits. So when we multiply this, we end up with 3.456. If I go with 2 significant digits, 1, 2, this is where we have to round to. 5 makes this go up to 5. So this is approximately equal to 3.5. Okay, it now has 2 significant digits. Looking at B, this is equal to 11.34. Okay, but let's look. 2 significant digits, 3 significant digits, and 1 significant digit. Because this 0 is after the significant digit in a whole number. It's to the right of it. Therefore, this 0 is not significant. So therefore, we have 1 significant digit. So the only digit we can keep is this 1 that's in the tens place. So this is approximately equal to the number 10. Okay, now look at C. That one is equal to 22.58904, and it keeps on going. So now we have to look at our significant digits. We have 4 and we have 3. Therefore, we're going to have to keep this number. Everything else is going to have to go. So this is approximately equal to 22.6, because it's going to have to round up. This is 5 or more, so round it up. D. That one is equal to 22.4. Okay? 2 significant digits, 3 significant digits. So we're going to have to round this to 2 significant digits. 4 is less than 5, so it's going to drop off. This is approximately equal to the number 22. E. 778610 is what the answer is. Now let's look at significant digits. I have 3 significant digits here and 4 here. So our answer can only have 3. 1, 2, 3. This is the place we have to keep. So this is approximately equal to 7, 7. 6 is going to make that 8 become a 9. 1, 2, 3, 4 places after that, so all of those will become zeros. And now you have 3 significant digits. Our last one is 9.86 with a repeating 6 on it. And how many digits are we going to have? Here's 3, here's 2. We have to have 2. So 1, 2, we're going to keep our 8. So this is going to be approximately equal to 9.9. So that's how you do significant digits when you have multiplication. Okay, now let's look at addition and subtraction. Since an idea of precision is used with significant digits, it's used for significant digits with addition and subtraction. Significant understanding precision is necessary. Is necessary. Okay, so what is precision? Precision is the place value of the rightmost significant digit. So if we look at the number 2.54, 4 is the rightmost significant digit, and it is in the 100th place value. Therefore, the 100th place value will be your significant digits that you keep when you do addition and subtraction. Okay. So now let's look at addition and subtraction. Let's do an example of this. Here's another number, 2400. Your last significant digit is in the hundreds place, and so therefore, when we go for significant digits, it's going to have to be in the hundreds place, okay? So now let's look at an addition example. 32.4, 2.05, and 2.32. Add these all up together and you get 36.77. Okay, so now, where are we going to route this? What is our significant digit say? Well, we're going to go to the one that has the closest after the decimal point. This one has the tenths, this has the hundredths, and this one has the hundredths. Therefore, we have to round to the tenths for our digit, And so this one is approximately equal to 36.8 because this 7 is going to push this one up 1. So that's how we do addition and subtraction. So now let's look at some practice on those. And again, like in the other, when you're doing the practice, put it on pause, try it, and then check your answers after you pause it. Okay, so let's look at some of these examples. $10.5 plus 8.72. 2.46, 3.517, and 4.8. Add those up. Okay, C is 47.5 minus 21.844. Okay, D, 56 minus 4.8. E, 325, 11.8, and 86.06. Add those up. And F, 0.027, 0.18, and 0.009. Adding them up. Okay, pause and then we'll come back and we'll actually work those, okay? All right, when we added this one, we got 19.22. Well, let's look at what is significant and what is precision. 0.5 here and 2 of them here. Therefore, we have to round it to our tens place value. So therefore, the tenths, which means here's my tenths place value. So this is approximately equal to 19.2. You add this one up and we get 10.777. Again, my tenths place value is the one that has the closest to the decimal point. Therefore, we have to round to our tenths place value, which is approximately equal to 10.8. Subtraction, 25.656. And now this is tenths and thousandths. So we're going to have to round to our tenths. 5 or greater pushes that 6 up, so this becomes 25.7. D, 51.2. Now this is the ones place value, so that's the closest to where the decimal point would be, and that's your last significant digit to the right. So therefore, this has to round to the ones, approximately equal to 51. My bottom one, you can't see that bottom number, so I'm going to write it over here. 422.86. Okay, 325 has a decimal point after that 5. Therefore, we have to round this thing to the ones place value, making this 423. Okay, and my last one, adding all those up, we have 0.216. Have to round to our hundredths place value, because that's thousands and thousands, so our hundredths place value. Round to this number here, so this is approximately equal to 0.22. 2, because that 6 is 5 or greater, so it's going to bump it up. Okay, that's it for that video. Have fun!